Good afternoon, everyone. Welcome to the webinar on Maryland Math Reform Efforts, Purposeful Pathways for Mathematics Pathways. My name is Nancy Shapiro. I'm the Associate Vice Chancellor for Academic Affairs at the University System of Maryland, and I welcome you to this webinar. I have with me a couple of my colleagues. I'd like to introduce them. Rebecca Martin, the Executive Director of NASH, the National Association of System Heads. She's going to speak in a minute. My colleague Alicia Marshall, who is the Associate Vice President for Learning at Anne Arundel Community College, and she's going to join me in doing this webinar presentation. I'd like you to know that you'll all be muted for the duration of the webinar, and what we'd like you to do is use the chat function of this webinar as a way for you to communicate questions or comments. And we were going to sort of go through our presentation, and then at the end, we're going to sort of open it up for discussion. So my colleague Stephanie Hall is going to be collecting your questions while we do the presentation. And so please don't hesitate to ask questions. Just use the chat function. Okay, I'm going to turn this over to Rebecca Martin for a few moments.
Good afternoon. This is, as Nancy said, Rebecca Martin. Welcome to this webinar. As you know, this is one of a continuing series of webinars that come from NASH, the Taking Student Success to Scale. We currently have 23 systems in this initiative that are working together to move the needle on improving student success and closing equity gaps. And if you go here, you can see your logo, and if you haven't joined us yet officially as part of this initiative, we would welcome you and hope that you will let us know what your interests and needs are as we move forward. As you know, NASH is focusing on 3 evidence-based interventions. We're using the power of our systems and in a collective impact approach in order to move together, not one campus at a time, but as groups of campuses in systems and a group of systems in this network. NASH chose 3 evidence-based strategies, if you back it up just for one more minute, to focus on during this work. 2 of them you've heard about on other webinars: high-impact practices for all students, guided pathways using predictive analytics, and then the one we're going to focus on today, redesigning the math pathway. We have made a lot of progress in the 2 years since we began. We got presidential recognition at the outset. We have developed virtual learning communities. We've got a webinar series that this is part of, and we had a network convening last April, and we'll be convening again this coming April in Denver. If you are interested in joining us for that meeting, please be in contact with your system lead for this initiative, because we really hope that you will be there. So today what we're going to do is take a deep dive into one of the very successful models in our network, which is has as its home the University System of Maryland, but as you will hear from Nancy and Alicia, this extends beyond the Maryland system to other partners in the state. So I'll turn this back to Nancy.
Okay, thank you, Rebecca. Okay, so for today, I wanted to talk about the goals for today's webinar. We have 3 goals for today. First, we want to document the shared challenge of remedial mathematics. I think that's why you're all here. I expect that the people who are on this call, this webinar today, have a sort of a lurking sense of anxiety around the rising number of students who come to us needing some kind of remedial math. So that's the first goal for today, to sort of document that shared challenge. Second goal is to describe a process that links a top-down and a bottom-up policy change strategy in a system and a state. And that's where I'm going to spend the bulk of my time. And finally, we're going to drill down to a campus level to sort of reveal the implementation successes and challenges that exist for individual institutions, because we can talk about it at the system and state level, but the work happens at the campus level. So what were the problems we were trying to solve in Maryland? What were we confronted with? I don't know if your data look anything like our data, but this is pretty frightening stuff. According to the Complete College America data collection and reporting, approximately 71% of Maryland's community college students and 24% of the four-year students test into some kind of developmental math course. That's a frightening statistic. As we sort of explored this challenge, this problem, we came to two other realizations. The first is that the existing regulations in general education in our Code of Maryland, it's called COMAR, drove community college students toward math courses that did not align with the requirements of their majors and resulted in high failure and dropout rates. And I am not sure how that plays in some of your institutions and your states, but it's worth taking a look at, what the policies are, what the regulations are. And the second thing that we uncovered was that Maryland institutions, USM institutions in particular, had multiple mathematics pathways for entering freshmen, but that community colleges, for a variety of reasons, which I'll discuss, did not. And that led to a really inefficient transfer system. So when these data became public, our General Assembly asked the big, heavy question, how much is this costing the state? And to our horror, the amount of money was pretty significant. You'll see that the research suggests that the community colleges were spending close to $7,000 per student for all remediation, not just math, but all remediation, up to close to $75 million. And the USM institutions were spending $9,000 per student, another $14 million. So you're talking close to 90, almost $100 million going into remediation every year. That's a public policy problem. And what we decided in Maryland at that point is that if we didn't try to do something about it at higher ed, they, quote, they, unquote, would. So it was sort of up to us to do it. So what did we do? Well, the first thing we did was host a statewide conference with the goal of coming out with shared common goals for undergraduate mathematics. The idea that we had a state that had certain expectations of higher education, we should be able to articulate what our shared goals were. And at that statewide convening, we had Uri Treisman, who many of you are probably familiar with, the director of the Dana Center at UT Austin. He came and he gave the sort of inspirational keynote speech, and he gave us the opportunity to arrive at shared goals. And these are the goals we had. To reduce the number of students taking remedial math, that's obvious. To increase the percentage of students who complete remedial math within their first year of college. Furthermore, to increase the percentage of first-year freshmen who complete credit-bearing gen ed math courses in their first year of college. Those are two separate but related goals. And the last one is to develop math pathways to place students in more appropriate courses for their educational goals and their degree programs. So I'd like to unpack that last bullet for a minute. With the Dana Center's help, they shared with us some fascinating data. These two pie graphs probably should sort of shout at you some recognition. The current college algebra to calculus pathways is an old pathway. It was actually formulated back in the 1950s to lead students from college algebra into calculus. But as you can see, current students aren't actually majoring in programs that require calculus. In fact, at community colleges, only 20% of the majors require a calculus, the fundamental math course or pathway. And at the four-year universities, only 28% require calculus. So we're looking at, 80%, 75% of the students in the entire higher ed system in the country probably are not in math courses or math pathways that are relevant to their majors. This was both a surprise to us and a revelation. At the same time that the Dana Center was collecting this kind of evidence, the Mathematics Association of America was doing a visioning process. I'm assuming some of you on the webinar are mathematicians and remember that in 2015, this visioning process came up with somewhat of the same kinds of conclusions. And this is a quote from their report. Faculty in disciplines outside mathematics rarely ask their students to find the equation of a line that passes through two given points. reflect on that in a moment. How many times have we done that in this past week? Not usually. But social scientists, for example, will expect students to recognize a linear pattern in a set of data, interpret the parameters of the line of best fit, and use the equation of the line to answer questions in the context of real-world scenarios. And that's actually the essence of what relevant math is about. So their conclusion or their recommendation is, they said mathematics science departments should be aware of applications used in other disciplines and adjust their general education and introductory courses accordingly. This is a direct quote from their report. That is a huge revelation in some ways, and it's also a heavy lift. We've worked with the Dana Center, and their perspective on this is that the mathematicians need to take the lead in this, which is sort of an interesting challenge. So I want to sort of lay that as a foundation. In order to accomplish the shared goals that I raised a few slides earlier, we actually came up with a process. And the process is heavily dependent on system leadership. So for those of you who are representing systems or who work within systems, I want to give sort of a shout out to the idea that the chancellor or the leadership of the system has an important role to play in this kind of policy conversation that can really shape the higher education conversation and action. In fact, our chancellor at the time, Chancellor Britt Kerwin, decided after the symposium where we decided on our goals that he would invite all the other segment heads of higher education, the community college leaders, the independent college leaders, and even the K-12 state superintendent, the segment heads, to become a steering committee that would help reform Maryland mathematics. And we called it the Maryland Mathematics Reform Initiative, MMRI. They became the Math Steering Committee. But you know, and I know, that steering committees can only take the work so far. They actually know, they're very knowledgeable, that it actually takes faculty grassroots work to make anything happen. And so in Maryland, they engaged the faculty through our statewide mathematics group and a series of campus-level committees and task forces. Now let me tell you a little bit about this special organization, this special group, the statewide mathematics group. These math faculty have been working together for over a dozen years. In some cases, a number of them have been around for almost 20 years. And they came together around the definition of general education mathematics, and they meet regularly across the state. This is a group that meets 2, 3, maybe 4 times a year, depending on how many issues there are, and they stay in touch with each other over email and internet, and they do the hard work of curriculum alignment in the state of Maryland. We call it the statewide math group. We have math faculty representatives from every higher education institution in the state, over 60 institutions, public and private, 2-year and 4-year. They have established core definitions for general education mathematics, and they recommend core course components of Math Gen Ed. They also identify expected student outcomes because in all of our conversations around mathematics and any course Gen Ed courses, the state turned away from the idea of common course numbering and talked about the common shared outcomes. But the shared outcomes of Gen Ed are a little harder to define, and so we need the faculty to help us do that. And here's an interesting point, the methods of measuring student Gen Ed competencies and outcomes. So this is a statewide group that really works. And finally, they share syllabi. So the syllabi, these are faculty work product, and they collaborate on this. So this is a very engaged group. We gave them a job. The steering committee, the MMRI steering committee, gave them a charge. They said, State Math Group, the current regulation is not accommodating of multiple math pathways. Can you fix it? The slide I have here is a very interesting example of sausage-making policy. Policy, that's sort of how to make policy. We started with the very simple statement on the left that the requirement in our regulations, our statewide regulations, say that Gen Ed Math should be one course in mathematics at or above the level of college algebra. Well, what stands out in that sentence, even though it's a nice, simple sentence, is college algebra. And if college algebra is the default math course for every Gen Ed math requirement, then you're going to end up where we ended up, which is a very, inflexible system. So the statewide math committee, math group, went to work. And what you have on the right side is the new policy. This is the policy that was adopted by the Maryland State Higher Education Commission, but it took about a year to formulate this policy through work groups. And I want to unpack it for you. I'll read it first and then I'll unpack. The new language of regulation is one course in mathematics having performance expectations demonstrating a level of mathematical maturity beyond the Maryland College and Career Ready standards in mathematics, including problem-solving skills, mathematical concepts and techniques that can be applied in students' program of study. So there are three parts of this that I want you to pay attention to. The first is a course in mathematics having performance expectations, okay? We're talking about outcomes. Based on not just any old set of standards, but based on Maryland's Common Core, high school Common Core standards. Maryland College and Career Readiness standards are Maryland's Common Core. So what we did in this policy is link higher education's Gen Ed requirement to the K-12 graduation requirement, which does a very important thing. It reinforces the importance of high school mathematics and the standard, and it demonstrates that there's a connection between what you learn in high school and what you can do in college. So that was an important piece. And the third thing that it does is it aligns it with the student's program of study. So here we have actually in regulation the requirement that the mathematics faculty and the disciplinary faculty of the other majors need to actually figure out what the right math courses are. This was a very significant sort of event in the history of our project. So there are three policy takeaways from this process so far. First is to take advantage of existing structures and relationships. We did that through our conference, we did that with the system leadership, and we did that with the math, the statewide math group. Second, create a space for open and frank dialogue. This is a place where you need to actually give people a chance to say what they believe and what they think, and then work through those issues. And finally, ground the work in these essential foundations. Agree on a common understanding of the problem, which we did. Share a belief that the problem is important and needs to be addressed, which we did. And make sure the right people are at the table. And we did that both through the steering committee and the statewide math group. So because we had this very strong foundation, we were actually able to take advantage of the request for proposals out of the U.S. Department of Education's FIPSE office, the First in the World grant. It just so happened that we were sort of already working on a bunch of these questions when the First in the World RFP came out. And we put together what I think was a very compelling proposal. In fact, since it was funded, it was a compelling proposal. And I want to tell you what were the elements of that proposal so you can take it and potentially learn from it. There are four components I want to mention. The first one is that we had a very diverse group of partners. We had four-year baccalaureate institutions. We had community colleges. We had institutions with competitive and open acceptance. We had HBCU. We had institutions with majority non-traditional freshmen, and we had rural institutions. We had 3 research-oriented institutions, and institutions ranging in size from 3,000 students to 85,000 students. So the first element of our proposal was really the diverse partners, which suggests the opportunity for scalability. The second sort of element and sort of part of our proposal was really a simple, clean research design. The research design is we wanted to take students who were 1 or 2 years below college-level math and accelerate their progress to a college-level math course. And so, through a quasi-experimental study, we have one treatment group. Students will be advised into a treatment group if they are non-STEM majors, and they will take this non-algebra-based developmental math course that will lead to a gen ed statistics course, and we're going to see whether that actually increases their success in gen ed statistics. The third component was a very carefully thought out logic model which demonstrates the linkages between all of the inputs, including the first in the world funding, and the outcomes that we desire. And while I'm not going to go through every element of this particular logic model, because I'm sure you've all seen logic models, I do want to stress the short-term outcomes, the fourth column, that our short-term outcomes are that we want students to pass developmental math. We want them to enroll in college-level statistics. We want them to pass college-level statistics, accumulate college credits, and hold positive views of themselves as learners. And that's just an example of the kind of logic model. And last but not least, we had what I'm going to call good bones. And by that I mean our math group, our statewide math group, had already been working very hard to develop the outcomes for three fundamental courses: the developmental math course, the general studies statistics course, and the topics for math literacy, a liberal arts math course. We had those in the works when we applied for this project, this grant. And as a consequence, we were funded with a $3 million grant from FIPSI to do this experiment to figure out whether or not our math pathway into statistics actually did accelerate student success. So with that, I am actually going to leave you with several policy questions, and then I'm going to turn it over to Alicia, who's going to sort of talk about the campus level work. So these are the policy questions that we are going to continue to work on through this project. We finished the first year of our project, and we're moving into year two. Well, actually, we're not finished the first year. We're sort of midway through the first year. But these are the questions that have arisen for us. How should we place students in the most appropriate math course? For any of you who are involved in mathematics placement, you know that all the placement instruments, AccuPlacer and the campus-level placement instruments, are pretty much algebra-based. So how are we going to figure out whether the students really need developmental courses if they're going into a different math pathway? So that's a problem for us. What's the best approach to leading faculty discussions about the rigor of different math courses? Again, any of you who have faculty who are teaching these various types of mathematics will certainly find there's going to be sort of the haves and the have-nots in mathematics, and can we discover the rigor in all the pathways? Third question, what's the best approach to starting the conversation between the mathematics faculty and the disciplinary faculty about relevant math competencies? Who starts it? Where do you go? Whose door do you knock on? Fourth, how should a system deal with transferability of these new courses? And finally, how can we bring the advising community to a better understanding of the new pathways? So those are the challenges that we're facing. We have 2 more years to do our project. We did a pilot study this fall, and we're analyzing the data now. But starting next fall, we're going to have our implementation year, and we're going to follow those students for their second semester and then into their third year. And meanwhile, we have to address all of these policy questions. So I am now going to turn this over to my friend and colleague, Alicia Marshall, and she's going to tell you how this works on campus. Okay, Alicia.
Yes. Good afternoon, everyone. I'm going to talk a little bit more about how this works at the institutional level. So I'm in from Anne Arundel Community College, and we implemented the new statistics pathway for our students in the fall of this 16-17 academic year. So I'm going to talk a little bit about that and share with you some of the benefits, some of the challenges, and some of the things that can probably answer some of your questions about institutional level implementation. So you can move to the next slide. So one of the benefits of working on this project was that there was collaboration across disciplines and actually across divisions. If you can take a look at this slide, you'll see who was the membership of our implementation team. And it was really driven by faculty, so you can see the largest number of members was from the math faculty. At the time, I was the math department chair, so I am continuing to serve as the institutional liaison, which means that I communicate with the other institutional representatives for all of the other institutions that are involved with the grant. And then we also had a representation from our education department. That faculty member worked with us on helping us to think about study skills integration into our course and our pathway. We also had director of testing because, as you can imagine, there was implications for placement for the students. As Nancy mentioned before, we were looking at students that were 1 or 2 levels below credit level placement, so we did have to include those individuals in the conversation, and our director of testing was very influential and helpful in that process for testing for our students. And then we also had an assistant registrar on our team, so we had a direct link to the registration, which was obviously an important piece as well, trying to help students register appropriately for the pathway, helping them to understand that this was a new option for them, and so forth. And then we also had our assistant director of counseling, retention, and advising. So advising was a big piece of the implementation where we did have that direct link with our team member from the advising department, but we also communicated with all of our advisors and as well as our admission counselors about the pathway and the opportunity for students so that across the college everyone was aware about it and everyone could communicate that to our incoming and our current students. We also had the Dean of Planning, Research, and Institutional Assessment on our team as well. So she helped to facilitate the data collection and to make sure that we were on track with that for the institution as well as for the information that we needed to provide to the grant in general. Can move to the next slide. So the bulk of the work in terms of what happened prior to our fall implementation was the curricular development. And we had faculty working on course development last spring and over the summer as well. And what we found out as part of this process was that although we were creating, through the grant, we were charged to create what we called a pre-statistics course, which is the course that we allowed students 1 or 2 levels below credit math to enroll in, and that course that would prepare them to take an elementary statistics credit level course upon completion, successful completion. That was our charge, but we found out as we started that process of trying to think about and develop a pre-statistics course that we also needed to re-examine our current elementary statistics course. And this actually prompted a discussion across the state where there were several institutions, as Nancy mentioned, part of the statewide math group. Several of the institutions that were represented in that group were also part of the grant work. And it really started kind of a natural discussion about elementary statistics where the statewide math group, although everyone wasn't necessarily participating in the grant, we started to talk about what was the course content for this elementary statistics course. And the group actually came up with a common course outline for elementary statistics. So that was, I would say, a benefit to our participation in the grant because now we had a common course outline for elementary statistics that we could use across the state, and then we could then build our pre-statistics course based on that. As I mentioned before, we did talk about integrating study skills in our course. We had seen success with our developmental courses prior to that where there was some integration of study skills, and we wanted that to be a necessary part of our pre-statistics course. So we had a member of the Teach Institute work with us on that. And the faculty really had the freedom to think about integrating best practices. And what we wanted the students to do at the end of the day was to be successful and to be prepared for their credit level coursework. So those conversations involved integration of active learning, making sure there was applications to the real world and project-based learning. And we also discussed the format for the course, whether it would be a lecture or a computerized format. At the end of the day, our faculty decided to offer the course primarily in a lecture format, but it also had computer components to it. So I've already mentioned some of the benefits that I've seen as a result of being a part of this work, but I will definitely say that the faculty and the students, when they found out, were really excited about this as an accelerated option. Our students who traditionally were 2 levels below credit math were really locked into taking 2 non-credit developmental courses prior to taking a credit level math course. With the introduction of this pathway, we were now able to eliminate one of those 2 courses. So our students were going to save time and they were going to save money. So that was an immediate benefit to our students, and we were excited about that opportunity. The other part of it, the other piece was to be able to have our students participate in coursework that was really more closely aligned to their program of study. So instead of having the majority of our students taking college algebra, which Nancy mentioned earlier in the presentation, college algebra to calculus was not necessarily a required math for the majority of our students' majors. We now had another opportunity for them to take a course that was more closely aligned with their program. So that was a benefit to us as well. We looked at this as another opportunity to participate in data collection where we could continuously evaluate our courses and our success rates. So we are a culture of evaluation and making decisions based on data in our department. So this kind of fell in line with that, and it was just another opportunity for us to look at how our students were doing and to see if there was a way that we could do something better. This was really a good opportunity for faculty who were interested in trying something different, who had ideas about delivery and ways to engage students, to get involved in creating a course from the beginning. And so this was exciting for some of our faculty who wanted to become involved, and also for those that were interested in increasing success rates for statistics, elementary statistics, since that's where our students were going. We were also excited, and I would say my faculty was extremely excited about the collaboration. The statewide math group, as a chair, as part of that group for a few years, I was used to working with faculty from both four-year institutions as well as community colleges like our institution. But our faculty that became involved in the grant really had a direct link to faculty at four-year institutions that they weren't used to having. And so this was a benefit to them, and also to be able to collaborate on coming up with a common course outline for elementary statistics. That was a wonderful experience, and really I think benefited all of our students in the end. So another benefit was the opportunity for improvement. I mentioned that a little bit, and our continuous kind of interest in improving student success. So we saw this as another way to do that. And one of the events that we held last April was having Dr. Uri Treisman, who's one of the senior advisors to the grant, to come and speak with our faculty and staff, as well as students. So that was a wonderful opportunity to talk to him and engage with him about instituting math pathways and aligning programs, math with programs of study. So we really had a lot of opportunities that we did not have prior to participating in this implementation. So along with benefits, there were also challenges. So I'm going to talk to us a little bit about that. There was a short time frame for what faculty thought in order to create the course and get everything up and running. So we did have a few challenges with that. But as I mentioned, our faculty were working diligently over the summer and really got everything done in the time that they needed to get it done with a collaborative effort. We also had a strange issue at our institution where we were currently offering I would say a co-requisite model where students were actually able to take a developmental course as well as a credit course, elementary statistics, in the same semester. So when we decided to become part of this grant opportunity, we had to deal with somewhat of a competition. That particular model was very successful, so we didn't want to get rid of that. But at the same time, we were excited about opportunities for students that were 2 levels below credit math and having a way to accelerate their pathway. So slightly different population of students, but we were also enveloping students that were 1 level below in this pathway, and those were the same students that would have been possibly interested in our co-requisite model that was offering both courses in the same semester. So we struggled a little bit with how to market this because there were somewhat competing options for students. And so we worked with our advising department on that, and we really advertised the benefits to students that were 2 levels below in some of those situations. And then we also looked towards students to really try to make decisions for themselves based on their own understanding of their pace and what they wanted and what they felt comfortable with. So some students really opted out of a co-requisite because they wanted to have a semester of developmental and then a credit course. So it did work out in the end, but we did struggle a little bit with that piece of it. And I want to speak a little bit about the data collection. We had anticipated that we would get more students than we did. So in our fall semester, we attempted to offer about 5 sections, and our sections for developmental are 25 students per section. We actually only ended up running 2 sections of the course, and I would say we had maybe about 20 students in one section and maybe about 15 in another. So the number of students was a lot smaller than we had anticipated, but we looked at that as a result of it being the first semester, and many of the students weren't really aware of the option yet. So we've seen a little bit of a bump in the enrollment for the spring semester, and we anticipate that that would continue. So where are we now? I've spoken a little bit to this, but you can probably summarize based on what I've told you thus far. We have our course. It's being offered currently, so we're in our 2nd semester of the implementation. We definitely have faculty who have been identified who did the development of the course, and those are the same faculty that are actually teaching the course. We did introduce a new faculty member this semester who's teaching the course, but most of the faculty that are teaching the course have been a part of the course development and are a part of the grant. We also have been able to tweak our materials a little bit based on the feedback that we've received from students and faculty after our fall implementation. So that was done, and hopefully to improve what we are offering for our current spring semester. And then, of course, we are continuing to communicate with our advisors and our mission counselors so that they are aware about the pathway and the options for our students.
Okay, thank you, Alicia. So now we actually have 15 or 20 minutes to have a conversation about what we have discussed with you so far today. And I have one question that's come in that actually is for Alicia. And the question is, are you doing anything special with advising to recruit students into the new courses? And how's that working?
I would say, as far as are we doing anything special with advising, we would meet with the advisors every semester, and we did it a little bit more frequently once we started to get involved with the grant. So the communication is there, and what we did was we laid out all of the options because, as I mentioned, we did have some competing options for students, and we tried to communicate to the advisors which option we thought was best for students. But in terms of the communication, the advisors seem to really have a good sense of what works for their students. So they would talk to the students about, you know, whether or not they felt that they were ready for a co-requisite type of experience where they would be taking a developmental course and a credit course at the same time, because we had that option as well, or if they wanted to take their time and do one semester. So and due to consecutive semesters. So we really didn't get too involved with that piece of it. We feel like as faculty, the advisors have a certain level of professionalism to their job in terms of advising. What we tried to do is work on the communication, make sure that the advisors knew who this pathway was for. We made it very clear that it was only for students that were heading to statistics, and that if a student was in a different program that required a different level of math, that this was probably not the right pathway. But we also try to continuously share the message to advisors that, that this was another option for general education math, as long as it aligned with their program. We tried to go back to that at the end of the day, but this was another way that students could meet that general education math requirement, and they did not have to all take college algebra. And we've been working on that message for a long time. I think probably before the actual grant became a part of our program. But that was what we did. We really communicated, and we let the professionalism up to the advisors about, you know, who they thought when they met with students, what they thought was best for the students.
Great. Thank you. So folks on the webinar, if you have questions, please send them into the chat space on the webinar space. I also want to thank UMUC, University of Maryland University College, because they're the ones that are hosting this WebEx webinar, so I really appreciate the work that the folks there have been doing for us. So Alicia, we haven't gotten a lot of questions. So maybe Alicia and I can continue the conversation a little bit. So let me ask you, Alicia, you know, at the institutional level, I mean, you've talked about the challenges. What would you say was the biggest hurdle that you had to overcome? And could you suggest to others who might want to try this pathway, you know, from your experience, what would you recommend?
I'm going to actually answer this question in a unique way, because I'm going to speak about what I think is the biggest hurdle for institutions in general that may not have been a big hurdle for us. Okay. One of the biggest hurdles, I think, probably with any kind of implementation of this level that involves so many pieces and so many divisions and folks, is that you have to get the buy-in. And I was just lucky that at our institution, I was a math department chair who had a dean who was a previous math department chair, and there was an understanding about what work needed to be done in mathematics, and there was always a support there. So I never really felt like I had to make a case as to why this was what we should do. But I do know that that's not the case at all institutions. So buy-in is really important from your administration. You need to have that support there, because obviously you saw the makeup of our team. It involved people that weren't faculty. There had to be some type of shared understanding across the divisions that said, yes, this is important, and yes, I need to send my advising person over there, and I need to send the assistant registrar to be part of this work. So that's something that we didn't have a problem with, but the buy-in, I think, is a big piece. And then also you've got to get your faculty to buy in. We have a pretty large department. We had about 30 full-time faculty, about 70 adjuncts at Anne Arundel Community College, and we did not have a problem with bringing everyone along in terms of the department being in support of this initiative, but it is, in some institutions, it may not always be that easy. So I would say that's the biggest piece, is making sure that everyone is on the same page and everyone sees the value in this work and that they're supportive of that.
Thanks. So I have one question that just came in, and the question is, where do you place undecided students? Can students begin in the new stats pathway course and switch to the college algebra pathway? Great question. That question actually was, so I'll respond to that, and then if Alicia wants to say something, add something, she should. But that was really one of the basic questions that our math folks asked at the beginning. And so Maryland has always had, not always, but, you know, for the past, 15 years or so, had a real focus on STEM pipelines, STEM education, STEM majors, STEM teachers. We're part of the general STEM movement, as I'm sure many of your institutions are as well in leadership. And we're constantly being asked how many STEM majors do you have and how many STEM teachers are you producing, those kinds of things. So the offering of alternative pathways does, if the idea for taking college algebra is to keep people's options open so that they can become STEM majors, then the alternative pathways does in fact create a hurdle for those students who choose an alternative pathway, a non-college algebra pathway, if they decide they want to be a STEM major. We came down on sort of more of a common sense perspective on that question. If students who come in as undecided majors don't have a strong math background, our belief, our thinking was that if we gave them a really good math experience, let's call it quantitative literacy or statistics, and they felt comfortable and confident and decided that they might actually want to become a STEM major as a function of having a good math experience, then we would build bridges for those students. We would work with, the institutions would work with those students, build some sort of bridges, give them summer programs, give them supplemental courses so that they could make progress toward being eligible to take the calculus. But our common sense told us that students who don't come in with a strong STEM, math background are less likely to choose to become STEM majors. So in that respect, we didn't think we were going to lose very many students that way. But Alicia, what's your thinking about that question?
Yeah, that was a challenge for us as well, and we really felt that we made it very clear, and as I mentioned earlier before when we were explaining this to our advising folks, was that this was a pathway to statistics, and that is where the students were prepared to go once they successfully completed this course. If they wanted to take college algebra, most often from there they would have to go back and take another prep course. And we would work with them on an individual basis, and if there was a way to get them there more quickly, we would work with that depending on, previous coursework and things like that, test scores and things. But we really tried to get our advisors to think about really making sure that the students, chose the pathway that was most appropriate for them based on what they thought they might want to do. And I know that's difficult because at a community college, the majority of our students don't have an idea yet of what they want to major in, and so it's hard for them to make these decisions. But it is really difficult for them to move from one pathway to the next pathway if they do change their mind. And I think that you gain a lot when you create pathways that align with programs of study, but unfortunately, you lose a little bit of that, the ability to go back and forth is not quite as easy. But I think in the end, it works out.
Yeah, I think it's really one of the conundrums of the Pathways model, and sort of, as we have conversations around the state, around the country, around the issue, what we're trying to solve, the problem we're trying to solve is that too many students are being placed in college algebra and it's not appropriate for them. And one of our research questions, we will bring some qualitative research studies of the students who are in these new math courses, and we're going to try to find out whether people feel that they were misplaced, whether they, when they realize that they can't now become, they're not going to be a doctor, and if they thought they were going to be a doctor, then somebody should have given them a different kind of advice about this. On the other hand, they are going to graduate from college, so if they didn't think they were going to graduate from college, this is going to allow them to sort of make progress toward that goal. So I think that the question,
there's not a clean answer to that question because we can't actually read students' minds, but it's a little bit like the question that our legislators ask us, why can't students graduate in 4 years? And the answer is, well, a lot of times because they change majors. And once, you can't dictate to them what they're going to major in. And if you can't do that, you can't control whether they can graduate in 4 years. Okay, so we have another question. Do you have system-wide documents to talk about the pathways and suggested math on that larger scale, or are these found more at the institution level? We do have system-level documents, actually the state math group documents. I would say they're state-level documents that define the elements of the 3 courses that the faculty develop, the developmental math course, we call them frameworks, the developmental math course, the intro statistics course, and the quantitative literacy course. And those, I can make those available along with this, the follow-up to this webinar. Those are documents that have been agreed upon by the state. So at that level, we have those, they are system-wide and they are statewide. And it matters that it's more than just system-wide because in Maryland, even though the community colleges are not part of our system, we get close to 50% of our students as transfer students. Not all of them from the community colleges, but some of them from out of state, obviously. But more than a third of our students come from the community colleges in Maryland. So any decisions and curriculum that we align as part of our meta level work or UBRA work really has to be vetted through both the community colleges and the four-year colleges, and those become public as part of the statewide math group sharing. Okay. Alicia, do you have any questions for me?
Yes. So one of the things I was going to ask you is pretty much a similar question that you asked me, but it's at the institutional level. What would you say was the biggest hurdle you had to overcome at the system level?
At the system level. Very similar to, in some ways to yours, a little different. I'd say that we had this diverse group of institutions that are part of our project, but the system is actually, the USM is a very diverse group in and of itself. Even though we don't have community colleges, we have, HBIs and community college, we have, and comprehensive universities, and we have research universities, and we have small universities and large universities, and part of the system challenge is meeting institutions where they are. It's not requiring exactly the same thing of every institution, because there are, in one of our institutions, there's only one tenured faculty member, and in another, there are, dozens of mathematics faculty members. So I think that at the system level, you have to pay attention to the on-the-ground context of, what's possible and how can you get the biggest benefit by collaborating across the system, understanding that not every institution is going to be able to put in the same amount of contribution, effort, whatever, but that everybody should benefit from it. So I think that it's really meeting the systems where they are would be my answer to that question.
Okay.
Okay. We have probably time for one more question. I don't see another one coming up on the screen. So I was going to ask Alicia whether whether you're worried about getting the math faculty to talk to the discipline faculty, or whether that seems to be okay on your campus and that's not what you worry about.
No, that's not, we really don't worry about that. We started engaging with the non-math faculty very early on to let them know about this as an alternative so that they could think about, whether or not they wanted to change their math requirement for their program. So it actually started a conversation, and we had those conversations regularly. You'll find, I think in a lot of institutions, you'll find that non-math faculty are highly concerned with mathematics because a lot of students in their programs, depending on what type of program they have and their students, that mathematics can often be the course that their students struggle with. So they are usually open to having conversations about math and what is the best math for their students in order to allow their students to be successful. So it really wasn't a problem at our institution, yeah.
That's good. So, from our perspective, I think that is going to be more of a challenge at some of the USM institutions, especially the ones that have large math, that are large faculties. So I'm thinking, for example, the University of Maryland at College Park, just as an example, or Towson University, which, with 30,000 students and, 5,000 faculty or whatever they have, it seems like somebody has to take the first step in asking the question. And so what we're going to be working on, and I think we do have to sort of model it, and I'm hoping that the places where it's working, like at Anne Arundel Community College and some of the others, can help share their process and their protocols and their models with the ones that haven't tried this yet. But some of our campuses are so large that they really don't talk across disciplines in that way. And it's really important for this kind of a project that we hear from the discipline faculty, whether it's the social sciences or the arts and humanities, or the health sciences, what exactly are the health professions that are not that are not so science oriented, how can they contextualize the best math for their students, and can they help the math faculty develop contextualized assignments so that they reinforce the work that's being done in math. And I can speak to this as my area is college writing, and I had this, writing across the curriculum was a big deal in the late 80s, early 90s. And talking to all of the departments, including the sciences, math, science, engineering, talking about the importance of writing to learn, that's essentially what has to happen with the math pathways work, I think. And so I think that there will be a second generation of work going on the campuses to have those hopefully important and productive conversations so that math becomes more relevant. Okay, I think we are actually coming close to time. So unless there are any other questions from the participants in the webinar, I would like to thank Alicia very much for sharing this time with me, and Rebecca, and thanks Stephanie for monitoring the questions, and thank Naz, who has been our wonderful facilitator for the WebEx. Thank you all very much. This will be recorded, and Nash will, you'll get some kind of information about how to access the recording, and if any of you are interested in seeing some of those system-wide documents, our information will be attached to the follow-up email, and I will be happy to send you the outlines of the courses and anything else that you think you might be interested in. So thanks again for joining us. Bye-bye.